Okay, welcome back. So, on the last video, um, we were revising about the determinant of matrices, and I said before we get into inverse of matrices, we before we need to to revise determinant, and before determinant, we saw transposed matrices, and so the order was transposed matrices, determinant of matrices, and today I wanted to cover with you about inverse of matrices. So uh, let me write this. Today we will talking about inverse matrices. And the first thing that I wanted to draw your attention is that in the context of matrices, let me type this, let me write this. In the context of inverse matrices, uh, this -1 is read as superscript. We cannot think this as a exponent. So this -1 is not a exponent, it's different of this 1 over a. So that means that uh, doesn't mean the reciprocal of a or 1 over a. But inverse matrix is similar to reciprocal of a number. So if you have a any number or a variable, in this case a x variable, if we do multiply by his reciprocal, which is 1 over a, we do get um, his the value 1. So the reciprocal of x is 1 over x or x, and on this case that is a exponent. So similar to a multiplication by of a number by his reciprocal, uh, when we have a matrix times his reciprocal, we do get the value 1, but on this case you will see that this is the identity of this matrix, and also when we do multiply by the inverse by the original, we do get the identity. And that is the first thing that I wanted to draw your attention. And if you remember, uh, a square matrix, identity matrix, is a square matrix with its main diagonal fill it out with ones, and the rest of the terms is 0, and this by and this is for a 2 by 2 matrix. Okay, so now let's also quick revise how to perform a multiplication of an inverse matrix to get the identity matrix as we multiply by his original. So let's say we have a matrix A and the entries are A, B, C, and D. And to calculate the inverse on this particular case, and I say particular because for matrix of order 3 by 3 or more larger is different. And in this case, we have to swap. So let me organize this in order. First thing, we have to swap A and D positions. The second thing to do is switch C and D. We have to swap A and D positions. Switch C and B signals. And divide by the determinant of this matrix. I really encourage you to revise this with more patience, because right here we are just passing quickly, because our main goal is in the context of robotics, and I'm facing this as an algorithm. So to do this calculus, the inverse. So let's let's follow these steps. Let's swap A and D positions. Okay, let's swap A and D positions. So right here is going to be D, right here A, and switch C and B signals. So it's going to be minus C, minus B. And divide by the determinant of this matrix. So if you remember, the determinant of A is calculated like this way. And another thing that I wanted to draw your attention is that we do not divide matrices by matrix by matrices, but we can divide a matrix by a real number. So to perform this, we do 1 over the determinant. Okay. So now let's solve a example. Find the determinant. Find the inverse of the 2 by 2 matrix below. And let's say that is a matrix with the entries 6, 5, 5, 4. And we will just apply this algorithm. So to visualize, to better visualize, I will put the letters as indicators. And so let's see. Let's first calculate the determinant of A, which is A times D minus B times C. And if you just do the multiplication on the diagonal, we will get the determinant, which is a scalar number. So doing this, we will get -1. And now let me copy this algorithm. And the inverse, let's swap D and A positions. So it's going right here, it's going to be 4. Right here is going to be 6 and 5 and 5. Times the determinant, which is -1. Actually, is we are dividing this matrix by the determinant, which is -1. But if we do multiply by 1 over -1, is the same as divide. And when we solve this, we are left with -4, 5, 5, and -6. And this is the inverse of the original matrix A. Now let's take a proof by doing the product between the original matrix and its inverse that we have just found. If our calculations are correct, we must obtain its identity. So if we do the product between the original matrix and its inverse, we must obtain his identity if our calculations are correct. So if we do this product, so let's take the original matrix A six, 5, 5, 4. Time its inverse that we have just found. And performing this multiplication, 6 times minus 4 plus is this 6 times this minus 4 plus 5 times 5, this 5 times this 5, 6 times 5 minus 6 times 5, and 5 times minus 4 plus 4 times 5, and 5 times 5 minus 6 times 4. And we do get his identity. So our calculations were correct, and that's its inverse. Okay, so we revise transposed matrix, determinant of a matrix, and now inverse of matrix. And I think now we are ready to get back on the book Robotics Introduction in Robotics from Said Pinico. And I do these three videos revising about matrices because I thought it was necessary to solve the income problems with more properties, because on the future problems we will have to calculate determinant, do transposed matrix, and all these stuffs that we have revised on these videos. So that's it. Hope you enjoy. Thank you.